Hi, my name is Nate Nisler, and this is for Hyperactive Studios. Right now, we're going to dive into loops, and these are basically repeating structures of programming code. This means we're going to repeat something a bunch of times over and over again. And it can make things a lot easier for your code, making it a lot shorter, but it does add a good bit of complexity to the code. So you'll have to learn how to think in more complex terms when using it, but it saves you so much effort. And there's a number of times where it's basically impossible to do the task without them. You'll see them throughout programming all over the place. It's a fundamental, absolutely have to know it aspect of coding. So it's good to just hop on it now and start getting it down. I'm going to throw arrays in there with it, and I'll get into that in just a second here. So basically, let's have a look at this. I could define a variable up here if I wanted, and this makes the variable what's called global, which means that everything in all our code can then access that variable. Versus if I declared a variable, if I created a variable or declared it as it's called inside of here, like I don't know, let's call a variable Sam. Sam is equal to Sam. I don't know, something like that. That variable only exists within the context of this function. So this is really useful because it means that you can have multiple variables with the same name, but they can be stored in different functions or methods. I'm sorry, this only exists within this def here. I accidentally selected this one too. Sorry. Um, so it means it only exists within this function. And that's really good because then you don't have to worry about if you had Sam, say, in another function and it was something totally different, it wouldn't conflict with this one over here. So that's very, very useful and makes life a lot better for a lot of stuff. Sam only exists when this function runs also. So Sam is automatically created in RAM and then destroyed from RAM. And I say RAM because all computer programs run in RAM and they don't run off a hard drive. They're read from a hard drive and stored in RAM, but your whole operating system and everything on the computer basically runs in RAM. That's why they say, you know, if you need to speed up your computer, add more RAM. That's why. So here in this case, I'm going to get rid of Sam. I don't need him. Sorry, Sam, we don't need you. All right, so we're gonna come over here, and let's say I'm just adding to our example here. Children. It's gonna be a global variable, and it's gonna equal to. I'm just gonna start out with an empty set. Let's just say there's nothing in here. If I wanted to, I could create, you know, several items in here. Sally. You might be going, well, now wait a minute. What is an array or a list? In this case, it's a list, technically, not an array, but they're very much alike. How about Bob? And maybe we have Billy. This is going to be a fun car ride right here. And then why not Jill? Jill sounds great. Awesome, and apparently they don't have uppercase letters for their names. I should probably change that. Sorry, guys. And gals. Alright. There we go. Awesome, awesome. Alright, so this means we have 4 people in our list, or 4 variables with 4 different values. So this is really cool. Say you have a grocery list, right? And you could call your list groceries, okay? And then you could put different items, different groceries, individual grocery, in your grocery list. You could also think of it like a purchasing cart. Like if you purchase checkout at on a website or whatever, and you're going to check out and buy all these items or whatnot. Well, it could be put into a list. So that each item that's going to be purchased could be put into a list. It could have its price and blah, blah, blah. So it makes a whole lot of sense. And so we can basically have one variable with a single name here like this, and then we can store multiple values in it. And that's what a list is. And therefore, I can then access each, aka element. So an element would be like Sally here. That'd be one element. That'd be one item in the list, if you will. Bob would be another element. Billy's another element. And Jill is yet another element. And one of the things that will really throw you off when you start learning a program is the fact that the computer starts counting at 0. Like you and I count at 1, start counting at 1. 1, 2, 3, 4, 5, 6, 7, 8. But the computer actually starts counting at 0, and it's actually part of its counting. It almost always, computer starts at 0, like 99.9% of the time. The computer starts counting at 0. And so you kind of have to get used to that. It'll kind of throw you off at first, but say I wanted to access an individual item in this list, I could say like 0, and then this will literally be Sally right here. If I wanted to access Bob, I'd make that a 1. If I want to access Billy, I'd make that 2. If I want to access Jill, she's 3. So we start at 0, 1, 2, 3, like that. And so that covers our whole list there. So that's kind of how that works. Now that I've made this variable global, I can then access it throughout the different functions in here, which is pretty cool. All right, so let's look at a few things here. Let's see here. Let's simulate. Let's create another function. Let's call it, make it a def here for the function. So there I created children, a list there with them already pre-assigned. Later on, I'll show you how to remove children and how to add them back in, append them back into our list. We'll look at that in just a second here. But first, I want to simulate car full of children. Awesome. It's our new function. All right. So before we were only dealing with one child, but now we can actually have several children in our awesome car ride. So what I'm going to do here is have a new structure called for. You haven't seen this before, but you're getting ready to. And then I'm going to say count, and in range. And they're like, oh my gosh, where is this coming from? Hold on, it gets worse. Length and children. There we go. Colon, enter. All right, awesome. And I probably just lost everyone, but hold on a second. We'll make it all make sense. No worries. Alrighty. I'm gonna copy that real quick. Alrighty, awesome. So one of the things we have going on here is this is going to repeat over and over again for each child. And that will actually work right there. And with that, I really don't need to have the car ride anymore in the main. Let me explain this. Hold on a second. I shall explain. No problem. It will all make sense in just one moment. Just want to kind of get some stuff out of the way because I don't want it. Okay, there we go. And that's now our main function. Okay, cool. So changed a little bit of stuff there. Let's go ahead and save now. Okay, so what does this do? This for loop is what's called a counting loop. It counts. I named my variable that's going to do the counting. I named it count. So it's going to store the different values in it. So what it does is we say for count in range. Range is a number range. So like if I were to do, say, like range 0, 10, close parentheses, it would start counting from 0 to 9. Okay, so we need to remove the parentheses here and here because it doesn't like it with the colon. It causes a problem for it. But if I go ahead and run this, but the thing is it starts at 0 and goes up to the number in the range. And so if I take, let me break this down easier. I'll tell you what. So let's do this where I'll show you what happens and then I'll explain it. And this will be the easiest way, teach by demonstration more or less. Okay. So let's do that right there. And we're going to say print, and I'm going to print count. Okay, let's go ahead and run this. It's going to ask me to save. And there we go. So it starts at 0 and goes up to 9. You know, why didn't it go up to 10? Well, kind of reason why is because this is the ending value. It automatically drops it off. This works out great for dealing with lists or arrays. And the reason why is because remember that our array up here starts at 0, right? So even though we have 4 elements in our array, or our list, or shall I say, sorry, list, um, you only count up to 3, right? So because this would be 0, 1, 2, and then 3 on Jill. So even though there's 4, we only count up to 3. So range kind of takes that into account automatically and drops 1 from the end. Really saves us a lot of effort and headaches. And then when we say length, length finds out how many elements are in our list. So it gets the length of the list. How many elements are in here? So we have Sally's 1, Bob's 1, Billy's 1, Jill's 1. So that's 1, 2, 3, 4 elements in the list. So it returns 4. So when we do len on children, we get back 4. Now if we had a 5th person added to this, then it would come back as 5. Very cool. And then in range here, it automatically defaults to start at 0. I said 0 here, but I could actually specify 5 and go 0 to, go 5 to essentially 9. And that would work. So you can change that, and you could even skip it by like how many, and do it by 2s, for instance, or do it by 3s, or by 4s, or by 5s. We should do it by 5s. You're going to have 1 there in that case, but you get the idea. So you can kind of do that with this range, and that's the whole gamut with range. But basically, saying in range here with the length of children, we're saying going from 0 to how many children there are in the range, because remember it defaults for this first number here to 0. So I really didn't have to put in that 0 there originally. I could have done that right there and get the exact same result, because the first one was the starting point, and if you don't give it 2 numbers, it automatically takes this as the ending point. So if you only have 1 number passed in, it's the ending point of it. I'll prove that. Bam. See, you got the exact same result, 0 through 9. I didn't have 0 in that range, but it still did it. That's because it automatically defaulted to 0. So same thing happens here with children. It starts at 0 and goes up to 4. Keywords up to 4. So it goes 0 to 3, which it works out great because that's how many children we have in our children list here. So this is really great because this is really dynamic. This means that things can change, and I don't want to put hard values like this typically when I'm doing loops. It's not a good idea. And the reason why it's not a good idea is because say we need to add another child to the list here of children. Well, if we do, then this hard number is not going to work, right? And then we have to sit there, increment it up later on, keep track of it the whole time. If we make a mistake somewhere in our program where we didn't keep track of it properly, then we're going to get an error. We're like out of bounds, or maybe we don't handle enough children for the way it's working, or something of that nature. So, you can have all these issues. But if I use a function like len to find the length of my list, then I get back how many elements are in that list. And if I use that for my range, I always loop the exact number of times I'm supposed to loop. Never one too many, never one too few. It always works, no matter what the situation. So I can sit there and have it, I could add a whole 100 new children or whatever to the list, and it would do it for all 100 additional children. And so we'd have like 104, right? Bam, so it'd be 0 to 104, which means it does 0 up through 103. So, that would work automatically. So that's pretty cool, and that takes care of finding the length of our list, and this sets up the range for it. Now, in the case of count here, we're saying this range automatically returns what? A number, right? Returns a number every time. And when we're saying count in the range, we're saying we want a number, grab us a number in that range, and it's going to work it up incrementally. So basically with this for loop like this, it's going to say for count in range, we're going to say the first number in range, in this case, is going to be 0, right? Because it defaults to 0. And then that'll be the first loop iteration. And then it goes through and loops again. And I'll just kind of show you this again. I was doing it a second ago. Let me undo that. It's code. Right? I actually proved that a second ago. Check this out. Right? First loop iteration, it displayed 0 because it got that from the range. Second loop iteration, it was 1 because it got that from the range. And 2, then 3, then 4. So every time it loops, every time it goes through and does the code, it's a loop iteration. It's that number is changing because it's within that range. It's getting it from the range. So a loop iteration would be every time it executes this line of code here, because that's the end of the loop. Or in this case, well, the counting one, I'm sorry. The counting one we just talked about, that'd be this line of code, right? So every time it gets to the end of all the code that's inside of this loop, which happens to be this one line of code, then it comes back and loops again. It checks, actually does a test. It says, hey, do we have anything left in the range? And the answer comes back. If it says yes, then we have to loop again, and it passes the whatever number it's on in the range to count, and count stores that number. And so that way when we go say print count, it prints out that number each time we're displaying it. That's what's happening there. So let's just talk this through real quick. All right. So first loop iteration, right? Count in range 10 here. What's count going to be? Well, range starts at 0 by default, so that means it passes the first number in that range as a list into count. So that'd be 0. So it passes 0 to count, and so now count in this example is equal to 0. So it comes down to print, and it checks what's stored in count. Count is 0, so it displays 0. Again, I'll prove it. Thus it says 0 right there. Then we go back up to our loop iteration. It says for count in range. So it says count, hey, loop does for loop here, hey, does it have any more elements in the range? And range goes, oh yeah, I got another one. This next one is 1. So it takes 1 and passes it to count, and so now count is 1. We come down here to print count, and count displays 1. Now I'll prove it again. Count displays 1. There it is. Cool. You get where this is going. Come back up here again to count for in range. We say count in range. I wish I'd done 5 or something like that. For count in range 10 here. It's now 2, right? Because it goes checks a range. Is there anything left in it? It says, yeah, sure is. There's 2 is the next one. I'll tell you what, I'm going to shrink this down a bit because I don't want to go through this whole thing. Let's make it like 5 or something. 4 maybe. I don't know. I don't care. Sorry. Okay, 0 to 4. Let's explain that one. It's shorter. I don't want to explain that many. So count in 2. Count is equal to 2, and it comes out to print it, and it prints count is 2. Awesome. So we go back up to count, and we say count in range 0 to 5, of course. By default, it's 0. We say, well, if count, is there anything left in range? It's going to say yes. There's a 3 in there now. That's what's left in there still. It says, okay, cool. And so it takes the 3 from range and puts it inside a count. And come down to print, and it displays 3. And I can prove that real quick. See, this makes it a much shorter example than this one up here, so that's why I changed it. Sorry. Probably shouldn't be changing it while I give an example, but I don't want to bore you guys too much. So count 3 there, coming back up here for 3, and count goes, hey, in range here, Mr. Range, do you have anything left in you? And range says, yeah, I do. I have a 4 left in me. So it passes the 4 to count, and now count is 4. So we come down here to print, and count, it checks, hey, what's the value of count? It says, oh, it's 4 in memory, so it displays 4. And again, we can see that right here. Awesomeness. Now let's talk about it a little bit more. All right, so we got a loop again. Oh yeah, no, it goes up for another loop. For count in range, and this is 0 to 5, and we say, hey, count, hey, range, do you have anything left in it? And range says, no, I sure don't. That was all the elements in the list. And the for loop says, oh, well, then we're done. And so then it skips this code, and it goes down to the next line. And then that's how that works. So same things happen here with the children, too. I'm just going to go ahead and remove this example now. For now. So same things happen to children. We're just getting those numbers back from range each time. And it's just printing it. We're just not using the count, but it is looping for the exact same number of elements that are in this list. So that is why we get repeated complaining. Are we there yet? Are we there yet? Are we there yet? Are we there yet? And then the parent is responding to each child as they're pulling the car over. Don't make me turn this car around and commit me now. So we have a lot more mayhem happening here now. But we can actually alter this a bit more and make it a little cooler. So let's try having a little more fun with this. And what we could do, instead of having a count and dealing with range, I want to show you a cool trick that you can do in Python. This is pretty cool. This is pretty neat. I can get rid of all that. You're probably going, you gotta be kidding me. Nope, we can just do that right there. And this will get each individual element, the value of the actual array, each element, and each element gets stored into whatever variable we say, in this case child. So that way I'm having a child as a part of children, right? So each child that we get out of children gets stored in child. So Sally would be a child. Bob would be another child. Billy would be another child. Jill would be another child. As we loop through each one of these items in our list element here. And so you might be going, well, why do I want to do that? Well, because check this out. If I come down here and say child, and say plus and plus like that, and then maybe add some spaces in there, something like that, right? Then the cool thing about all that is we can actually say what child is saying this stuff, right? So that way we can actually specify which child is it that's complaining at this point in time. So if I say run module, Sally, are we there yet? Are we there yet? Are we there yet? Are we there yet? Don't make me turn this car around. Bob, are we there yet? Are we there yet? Billy, Jill, etc. It's kind of running together though. It's getting a little hard to read since we have all these children. So something I want to do probably just to help space things out, let's come down here into print. Spell print correctly. That's always helpful. Maybe I want to put a colon in here just so I can tell shows what. And by putting this print statement in here, it actually is going to separate this blank line because I didn't put anything in the print. So let's give me a blank line when I go to run this at the end. Pow. And so now we get a little prettier, right? Sally, are we there yet? Are we there yet? Are we there yet? And it says, are we there yet? And then I will pull this car over. And then Bob also makes him say, or her say, that I will pull this car over. And then Billy here says, just like, are we there yet? And he just gets a no because he wasn't as annoying. And then Jill just makes the driver want to be committed to the insane asylum. So that's awesome. Let's go over here. And that is how a loop can work, where we can loop through each element in the loop with this for statement. And that's also how you can use lists or arrays with basically a loop. So this is really cool because, and that's why I have a lot of books will try to separate the two and try to teach lists separately from loops, but I really I think loops and lists and arrays kind of just go hand in hand with each other, where, you know, if you have a loop, you really pretty much want to use a list to go with it, because a lot of times you're going to be looping through things, and so a list just makes a whole lot of sense that you're looping through each element in a list. And that's how we primarily use lists most of the time, is looping through elements in something. Almost always. It's just the number one fundamental way we use them. And we can have lots of code in here inside the loop, but essentially that's pretty much how we do it. And so this is pretty cool. You see, normally you start to see the power of functions and loops, because, right, if I didn't use this as a function, what would I have to do, right? And if I didn't use loops, what would I have to do? Well, I would have to write out the parent response code here over and over again a bunch of times, right? So I'd have to write out this code like 4 times. And then to top it off, I would also have to write out this code here 4 times. And if I made a mistake, I'd have to go back and try to find it and fix it. And so it just kind of gets annoying. And so having loops here where I can call a function with list elements, it saves you so much work. It's so much faster to code it. It's so much easier to code it, but the logic is more complex. So you have to learn to think in more complex manners but what saves you in time and effort is after a while, like at first it's scary, but after a while it gets really easy to use them, and you'll start to do loops without thinking about it. But at first it's a bit much to take in. So anyhow, we'll look at some more examples, and we'll do some more complex coding with these loops. The loops can get kind of you start putting things in loops. You can put loops inside of loops. You can put loops inside of loops. The idea. And so it gets kind of complex. One of the ways you can help break down that complexity, though, so you don't have to think about all the complexities of all the different loops working, so you can break them into more functions. And so separating things out into functions can actually simplify things. Not only that, but you can also test each piece better, make sure everything's working correctly. And then when you nest them, then things just work correctly. And it also makes the code cleaner and easier to read. So you wouldn't use functions for every loop if it's not complex enough. It wouldn't make sense. But if you start getting a loop that's kind of complex, you might want to start breaking stuff into functions, simplifying your code, making it easier to debug, and then basically making it easier to read the code and work with it in the future. I mean, you might even have to use those functions later on in another part of the program. So that's part of the program design. We will eventually get into how to do program design, like how to break down, how to solve things. But basically, doing a good logical layout and how to break the code down to smaller pieces that are reusable and reusing them in many ways as possible saves you a lot of time and effort coding it. But not only that, it also saves a lot of time and effort when you're trying to maintain the code too. So if you have to come back and like fix something or fix problems with the code, if you have shorter, simpler code, it makes it a lot easier to fix and update things. Not only that, it also tends to make programs run faster too. So if less code means runs faster. Yeah, so it kind of matters. So keep your code short, sweet, and pretty, easy to read, easy to maintain, easy to update, easy to reuse. Then that's your best bet. You're best off in that manner. So with that, though, hopefully you found this interesting, and we're going to dive into more loops here in the next video. And we're going to show you a different type of loop called while loop. It's extremely useful. You'll find it really neat. This loop's a counting loop, but a while loop is going to be based on the condition. We're going to continue to loop over and over again while something is true, and the moment it's no longer true anymore and it becomes false, then we stop looping. We're going to go over that in the next video. We're also going to go over some more cool stuff you can do with this, and just some more interesting things in general with it. But with that, that was going over for loops with lists. And my name is Nate Nestler, and this is for Hyperactive Studios. Thank you very much.